Good morning, students. In the last class, we have seen what about the reaction of these aldehydes and ketones with ammonia and their derivatives. And we are remained with one more thing. Before going to one more, what are the ammonia and its derivatives? Suppose first one, if it is ammonia, if Z is equal to H, what is the product we will get? That is amine. Next, if it is RNH2, means Z is equal to R, then we will get substituted amine, that is called Skipp's base. Next, if it is NH2OH, hydroxylamine, Z is equal to OH, if it is hydroxylamine, we will get oxime. Next, NH2NH2, hydrogen, Z is equal to NH2, then we will get hydrogen. Next, phenyl hydrogen, we will get phenyl hydrogen. Okay, 2,4-DNPH, 2,4 dinitrophenyl hydrogen. When it reacts with aldehydes or ketones, we will get 2,4-DNP zone. Actually, that is 2,4-dinitrophenyl hydrogen. That is orange red precipitate. That is used as test to identify aldehydes or ketones. That one we have seen now. And one more thing it is remained. That is, what is the Z group? What is the reagent? Reagent name, product. Z is nothing but NH C double bond O NH2. Z is nothing but NH C double bond O NH2. We have the common formula for reagent, that is NH2Z. NH2Z. In that, Z is nothing but NHCONH2. Then this reagent name is semicarbazide. This reagent name is semicarbazide. And what is the product to be formed? The product is C double bond N NH C double bond O NH2. See here, this H2 and carbonyl carbon oxygen will be gone out and we will get C double bond N, continuation Z, NH C double bond O NH2. This is the product to be formed. Name of this product is semicarbazone. Name of this compound is semicarbazone. Okay, this is the last one under ammonia and its derivatives. By this ammonia and its derivatives, the topic is completed. Even nucleophilic addition reactions, the total thing is completed. Examples. Under examples of nucleophilic addition reactions, we have seen reaction with HCN to form cyanohydrin. Reaction with NaHSO3. What is the substance to be formed? We have seen. Next, reaction with Grignard reagent. Reaction with Grignard reagent, we will get alcohols. Next, reaction with alcohols, we will get ketols and acetols. Next, reaction with ammonia and their derivatives. This is by this that examples for nucleophilic addition reactions completed. This is totally under first part, that is nucleophilic addition reactions. Okay, under nucleophilic addition reactions side heading, we have seen mechanism of nucleophilic addition reactions. Please carefully listen to me. Mechanism of nucleophilic addition reactions. Second one, reactivity of aldehydes or ketones towards nucleophilic addition reactions. Aldehydes are more reactive than ketones, like that we said. Third one, some examples. After that examples, we have seen reaction with HCN, reaction with all these things, we have seen under examples only. This is totally under part first one, chemical properties of aldehydes and ketones. Under that first part, that is nucleophilic addition reactions. Carbonyl compounds will undergo nucleophilic addition reactions. Under that, these are the things we have covered. So first reaction is completed. Under chemical properties, only one is completed till now. Okay, next, second one. Second one, that is reduction. Under reduction, small one, cardinal compounds, those are aldehydes or ketones. Aldehydes or ketones, they will undergo reduction to form alcohols. We know aldehydes or ketones, they will undergo reduction to form alcohols. Then already we know another types of reactions what we have seen under the reduction mark. If you take any aldehyde, C double bond O, CH3 C double bond OH, it will undergo reduction in presence of LiAlH4 or NaBH4 or hydrogen such that palladium, platinum, nickel. Any catalyst we can use, they will undergo reduction to form CH3 CH2OH. Primary alcohol. Aldehydes will give primary alcohol. Ketone will give CH3 C double bond O CH3 LiAlH4. We will get CH3 CH2 CH3 CHOH CH3 CH3 CHOH CH3. This is secondary alcohol. Aldehydes will give primary alcohol, ketones will give secondary alcohol. Okay, ma? This is about reduction under that subheading 1. One more type of reduction cardinal compounds will undergo. That is under named reactions we will see them, ma? That is second one. Under second one we have two named reactions, ma? Those are first one, A, Clemmensen reduction. Very simple only. Clemmensen reduction involves reaction of C double bond O with zinc amalgam such that HCl. Reaction of C double bond O with zinc amalgam such that HCl. Zinc amalgam is nothing but it is a alloy of zinc and mercury. The amalgam is a substance, it is an alloy in which mercury is the common constituent. If it is sodium, sodium amalgam. If it is zinc, zinc amalgam. Like that, mercury is mixed with any other metal to be formed as an alloy. That is this one. Okay. Now, actually this metal will react with HCl to produce hydrogen gas only. That hydrogen is going to be reacted with this cardinal carbon to be converted to, here C double bond O is there. That C double bond O is converted to CH2. Completely, the bond completely will be broken, man. Here two hydrogens, here two hydrogens. That is separated from reaction between zinc, mercury amalgam and HCl only. Hydrogen will be generated. Okay? See, C double bond O is completely converted to CH2. Here, Clemmensen reduction, after that we will see one more reduction that is called Wolff-Kishner reduction. Both Clemmensen reduction and Wolff-Kishner reduction are involved with conversion of C double bond O to CH2 group. These two are highly useful in conversions. Sometimes in conversions, they will ask that how do we convert that C double bond O to CH2. In that condition, these two reactions are useful. Okay, now we will see what about B. That is Wolff-Kishner reduction. Generally, aldehydes or ketones will undergo reduction to form alcohols only. Correct. But these two are exceptional cases, right? C double bond is converted to CH2. You need to remember very nice. We have to remember very carefully. Okay? Now under this Wolff-Kishner reaction, C double bond O, it is going to react with hydrogen NH2, NH2. NH2, NH2. Then this double bond O, this oxygen and H2 will be gone out as H2O. This reaction already we have seen in ammonia derivatives. This double bond O and H2 will be gone out as H2O. We will get C double bond N NH2. C double bond N, NH2. Which gives rise to reaction with KOH reaction with KOH in presence of ethylene glycol. Ethylene glycol. ETHYLENAGLYCOL, ethylene glycol. Here the bond will be broken. This is nothing but hydrolysis only. KOH says that ethylene glycol, it is nothing but hydrolysis only. Here the bond will be broken. Here oxygen will be. Here H2 will be. Then again we will get hydrogen, NH2, NH2. Along with C. Oh, sorry, no. 1 minute. Sorry, here H2 will be. Here oxygen not. Carbon side 2 hydrogens, nitrogen side oxygen. Then it is getting as carbon H2. Okay, conversion of C double bond O to CH2. Conversion of C double bond O to CH2. These two reductions are very important, and the name reactions are also very important. No? First one is Clemmensen reduction and second one is Wolff-Kishner reduction. This is coming under reduction reaction. By this reduction is completed. Now once again, C double bond O is converted to CH2 by reaction with zinc amalgam such that HCl, or reaction with NH2 hydrogen. Second step, KOH ethylene glycol. In this way, C double bond O is converted to CH2. Okay, no? In the conversions, while we are doing the conversions, you can understand the importance also, no problem. First, this is about reduction reaction. So under reduction reactions, two we have studied. Those are, first one, aldehydes or ketones will undergo reduction to form alcohols. Aldehydes will undergo reduction to form primary alcohol. Ketones will undergo reduction to form secondary alcohol. Second type of reduction is this. Aldehydes or ketones, C double bond O, will be converted to CH2. Okay? By the following reagents. Zinc amalgam such that HCl. That reaction is called Clemmensen reduction. If it is NH2 NH2 hydrogen and hydrolysis, that is called Wolff-Kishner reduction. This is about reduction. Shall we go to next one? That is oxidation. That is third one now. Oxidation. We know when aldehydes are ketones, they will undergo oxidation. We will get carboxylic acids. Okay? Now, same thing we will study here. Under this, if you take aldehyde, CH3, C double bond O, H. If it undergoes oxidation with any weak oxidizing agent or KMnO4, no problem, anything, it will undergo oxidation. Okay? Because here this is not alcohol to acid, it is aldehyde to acid. Now weak oxidizing agent is also okay to convert that aldehyde to acid. Now how many carbons aldehyde has? 2 carbons. We will get carboxylic acid with 2 carbons. If aldehyde undergoes oxidation, we will get carboxylic acid with same number of carbons. So there is no difference at all. This is one of the important points we have to remember in conversions. Sometimes they will give in conversions hints regarding carbonyl compounds, but they will give that carbonyl compound will undergo oxidation to form acid with same number of carbons. Then we can understand it is aldehyde. Like that they will give some hints. Okay, to find the structure by giving molecular formula. Next, second one. If ketones undergo oxidation, what is the thing? It will be observed. Let us see that one. Let us consider CH3, C double bond O, CH3. Before going to ketones, okay, here, what about ketones classification? We will see. 2 types of ketones we can have. Those are symmetrical ketones. What is meant by symmetrical ketone? The C double bond O, if it is bonded to same alkyl groups. The C double bond O is bonded to same alkyl groups, then it is called symmetrical ketone. C double bond O, if it is bonded to same alkyl groups, then it is called symmetrical ketone. If the symmetrical ketone undergoes oxidation, okay, see, the CH3 C bond or the CH3 C bond, any one bond will be cleaved. Here this is symmetrical ketone, any bond can be cleaved, no problem. The CH3 C bond or this CH3, anything same only. Now I am going to cleave this bond now. After cleaving this bond, means breaking of the bond, right side, how many carbons we have? 2 carbons. So we will get carboxylic acid with 2 carbons. Right side, how many carbons we have? 2 carbons. With 2 carbons, what is the carboxylic acid present? That is CH3COOH. These are all straight chain only, man. Okay, while we are writing, you will understand, no problem. See, this is one compound plus left side, how many carbons we have? 1 carbon alkyl group. Even it is also oxidized to carboxylic acid. Even left side substance is also oxidized to carboxylic acid. How many carbons we have? 1 carbon. So carboxylic acid with 1 carbon will be formed. That is HCOOH. HCOOH. When ketones undergo oxidation, ketones contain 2 types of ketones, symmetrical ketones and unsymmetrical ketones. Now we are talking about first symmetrical ketone. If this ketone undergoes oxidation, we will get carboxylic acids, mixture of carboxylic acids with carbon atoms less than the carbon atoms present in ketone. In ketone, totally how many carbon atoms we have? 3 carbons, but this carboxylic acid has 2 carbons, this carboxylic acid has 1 carbon. But total carbons present in the carboxylic acids will be equal to total number of carbons present in ketone. That is okay. But we will get mixture of carboxylic acids with carbon atoms less than the carbons present in ketone. That is the point we can remember. That is the difference between aldehyde and ketone oxidation. Aldehyde will undergo oxidation to form carboxylic acid with same number of carbons. Aldehyde will undergo oxidation to form carboxylic acid with same number of carbons. But ketone will undergo oxidation to form mixture of carboxylic acids with definitely carbons present in less than the carbons present in ketones. That is the thing we have to remember. Under that, we have seen first symmetrical ketone. No? Next, we will see unsymmetrical ketone also. Okay, shall we go through that one? You understood this correctly. If it is symmetrical ketone, we can break bond, left side bond or right side bond, anything. We will get same products only, no problem. Now, if this bond is cleaved, right side remained with how many carbons? CH3CO, 2 carbons. Carboxylic acid with 2 carbons we wrote. Left side, how many carbons we have? 1 carbon. Carboxylic acid with 1 carbon we wrote. These are the mixture of carboxylic acids which are obtained by oxidation of symmetrical ketone. Now, unsymmetrical ketone, if it undergoes oxidation, let us see that one. Shall I rub this one now? CH3, C double bond O, CH2, CH3. If C double bond O is not bonded to 2 same alkyl groups, that is called unsymmetrical ketone. If C double bond O is not bonded to same alkyl groups, that is called unsymmetrical ketone. Now this unsymmetrical ketone undergoes oxidation to form. Actually, in our C-based test book they give by possibility of left side bond and right side bond. Both possibilities they have written. Now I will show. After that I will say what is the major product also. Okay, see, let us give numbering. This is 1, this is 2, this is 3. Okay, now first cleavage of C1 C2 bond. If this unsymmetrical ketone undergoes oxidation, two cleavages will be happen. Those are C1 C2 bond cleavage as well as C2 C3 bond cleavage. Okay ma? Now first cleavage of C1 C2 bond. That means this bond is cleaved. If this bond is cleaved, left side how many carbons we have? 1 carbon. We will get acid with 1 carbon. Right side how many carbons we have? 3 carbons. Acid with 3 carbons. This is straight chain only. CH3, CH2, COOH. Straight chain only. No need to get any isomer idea. Okay. Because how this straight chain, how this chain is present, in that way only this is converted to COOH. C double bond O alone, it is converted to COOH. It is bonded to what is the chain? That chain will be remain as it is. Now the carbon compound, that is CH3, CH2, COOH. These two are the products when C1 C2 bond will be cleaved. Okay, next. Cleavage of C2 C3 bond. Cleavage of C2 C3 bond. Then here the bond will be cleaved. Now left side how many carbons we have? 2 carbons. Right side 2 carbons. Then we will get carboxylic acid with 2 carbons plus carboxylic acid with 2 carbons. Totally 4 carboxylic acids we will get. In that these two are same. So this is called butane-2-one. When butane-2-one undergoes oxidation, we will get formic acid, propanoic acid and ethanoic acid. These two are same now, that's why I combined them. Okay? Formic acid, propanoic acid and ethanoic acid. In what way it is undergoing? You have seen this one. By the cleavage of C1 C2 bond as well as C2 C3 bond. Like this we will get, if these two are also different, we will get 4 carboxylic acids. Okay, I think you understood this one. But in our any competitive exams or in our even CBSE books, CBSE exam also, sometimes they will ask, there is a chance to get asked with major product in this one. Then we will say, what is that major product according to one rule. That rule I will write now. Okay, ma? That rule is called Popoff's rule. According to Popoff's rule, if a ketone undergoes oxidation, okay, we will get major product in a way that this C double bond O carbonyl group will be stayed with alkyl group with less number of carbons. Will be stayed with alkyl group with less number of carbons. So the cleavage will be happened here. In unsymmetrical ketone, definitely 2 alkyl groups are present which have not same number of carbons. Correct? In unsymmetrical ketone, carbonyl carbon, that is C double bond O, is bonded to 2 alkyl groups without same number of carbons. In that condition, definitely alkyl group with less number of carbons will be staying back with C double bond O, and other one, that side it is broken. Now we will get what are the products, say, if this bond is cleaved. CH3 COOH plus carboxylic acid with 2 carbons, carboxylic acid with 2 carbons, CH3COOH. These are the major products. Previously we have seen 2 types of possibilities. In the 2 types of possibilities, which possibility is dominating? C2 C3 bond cleavage is dominating according to which rule? Popoff's rule. If they don't ask anything major product, both possibilities in what way we have written, please write them. If they ask any major product, then we have to follow this Pop-ups rule. Now what is the Pop-ups rule? If ketones undergo oxidation, the carbonyl carbon stayed with, or it is remained with, alkyl group with less number of carbons. C double bond O is stayed with alkyl group with less number of carbons. Then where the bond will be cleaved? C2C3 bond will be cleaved. In that way we have to write the major products. If they don't ask any major products, immediately we can write all the possibilities. C1C2 bond cleavage as well as C2C3 bond cleavage. By that, what are the mixture of products we will get? Mixture of carboxylic acids. All the mixture of carboxylic acids we have to represent clearly. That is about unsymmetrical ketone oxidation. So we have seen aldehydes undergo oxidation. They will form simply carboxylic acids with same number of carbons. All ketones will undergo oxidation in two ways. Unsymmetrical ketones and symmetrical ketones. Symmetrical ketones, again, no problem. Any side bond cleavage will be same because alkyl groups are same on then we will get according to the carboxylic acids. But if unsymmetrical ketone undergoes oxidation only, we will follow Pop-ups rule to say that major product. Otherwise, what are the possibilities we have? All the possibilities we will write now. Okay, this is about oxidation reaction. We completed third one. First one, nucleophilic addition reactions. Second one, reduction. Third one, oxidation we completed. So we will continue this topic now. Then fourth one. Under oxidation, further some reactions are remaining. Sorry for this one. This is nothing but continuation oxidation only. We have some differentiating tests between aldehydes and ketones. That is coming under here, those are mild oxidizing agents. Mild means very low oxidizing agents. Those are, what are the tests useful? Now we will see them. First one, under this oxidation, first we have seen aldehydes will undergo oxidation to form carboxylic acids. Ketones will undergo oxidation, we will get mixture of carboxylic acids. Next, continuation, third point. Okay, first aldehydes, second ketones, third this one, tolerance test. Tolerance test will be shown by tolerance reagent. What is meant by tolerance reagent? Ammonical silver nitrate solution. Is called tolerance reagent. Actually, ammonical is nothing but ammonium ion is present. Okay, silver nitrate AgNO3. This total solution, ammonical silver nitrate solution, is called tolerance reagent. But while we are writing the reaction, those two will undergo reaction to form one complex, that is silver ammonia complex. Silver from here and ammonia from this one, it will be formed as silver ammonia complex. Okay, ma'am? Let us see. AgNH3 twice plus. Actual reagent is ammonical silver nitrate solution only, but combinedly we are going to write tolerance reagent as this one complex. Silver ammonia reacts with silver to form a complex, that is AgNH3 twice plus. Okay, ma'am? Aldehydes, this tolerance test will be shown by tolerance test. Next we will study valence test. These two are shown by aldehydes only. Ketones, they won't show these tests. Okay? RCHO will undergo reaction with AgNH3 twice plus complex to be formed as, this aldehyde will undergo oxidation. Aldehyde will undergo oxidation to form carboxylic acid. R C double bond O, O minus, carboxylic ion is formed. Carboxylate ion or carboxylic acid, both are same only, no problem. RCHO plus AgNH3 twice plus reacts to form RCOO minus plus NH3 here plus 2Ag plus H2O. In this reaction, what is happening? See, RC double bond OH is converted to carboxylate ion. It is undergoing oxidation. Okay, ma? Now, Ag in this complex, it is present in the form of Ag plus. Ag in this complex, it is present in the form of Ag plus. What is the oxidation number? +1. Charge present on silver is +1. Right side, it is converted to Ag. Ag means elementary form. It has same number of electrons and protons. Then it has charge 0. Plus oxidation state is converted to 0 oxidation state. Decrease in oxidation state, which is called reduction. So this silver which is present in this complex, that is in the form of Ag plus, will undergo reduction to form Ag. This is formed as silver man. This is silver only. It is formed as mirror on tissue. That is why this is called silver mirror test. This is also called silver mirror test. This silver mirror test video, after seeing this class, I will send to you. No problem. Okay, like yesterday I sent for your 2,4-DNPH test. Like that. First, if you go through the class, after that I will send tolerance test, how it is happened, what is the silver mirror, how it will be formed, I will show that one. This is done by only aldehydes, shown by aldehydes. Ketones won't show this one. This is the differentiation test between aldehyde and ketone. We can see with our eyes. Now once again, aldehydes will react with AgNH3 twice plus. This is nothing but tolerance reagent. Okay, what is going to be happen? In my lab, I have done this one. The given compound is aldehyde or ketone, we want to know. First, I have done with given compound with 2,4-DNPH. I got orange red precipitate. By that, what we will understand? Whether it is aldehyde or ketone, we don't know. But definitely it contains C double bond O. Because of that one, it reacts with 2,4-DNPH to form orange red precipitate. Then, after getting that information, we have to know whether it is aldehyde or ketone, correct? Because we have to find finally functional group. For finding the functional group, we have to understand whether it is aldehyde or ketone. Then, by using 2,4-DNPH test, we understood that that is carbonyl group. After that, we will perform this test. Then this is useful to distinguish aldehyde or ketone. Then in what way? The given compound is taken in a test tube. Into the test tube, already prepared tolerance reagent will be there. They will keep the label, that is tolerance reagent. The tolerance reagent I will add to this one. Okay, and this test tube I heated on Bunsen burner. After some time, this aldehyde will react with that tolerance reagent to be formed as silver mirror. On the test tube, clearly it is visible, silver mirror is going to be formed. Okay, by seeing that we can understand the given compound has aldehyde. If it does not form silver mirror, we will come to know that is ketone. Even how much time if you heat also, if you don't get silver mirror, that is nothing but ketone. Ketones won't show tolerance test, but aldehydes they will show tolerance test to be formed as silver mirror, silver. Here, this one is undergoing oxidation to be formed as RCOO minus. Ag plus undergoes reduction to form Ag. This is the reaction about tolerance test. Okay, ma'am. Next, shall we see that fourth one, that is failings test. Under oxidation, that is fourth one. Failing test. It is also shown by aldehydes only. Failings test is performed by failings reagent. Fehling's reagent is mixed with, this is addition of Fehling's A solution and Fehling's B solution. Two test tubes we will take. First test tube is filled with Fehling's A solution and second test tube is filled with Fehling's B solution. Both test tubes are mixed into one more test tube, that is called Fehling's reagent. So Fehling's reagent is the addition of Fehling's A and Fehling's B. Now what is meant by Fehling's A? Fehling's A is nothing but aqueous copper sulfate solution. Copper sulfate, if it is dissolved in water, it will be formed as blue colored solution. That aqueous copper sulfate solution is called Fehling's A solution. Next, Fehling's B. Fehling's B is nothing but alkaline solution of sodium, potassium tartrate. Alkaline solution of sodium potassium tartrate, that is called Fehling's B solution. Now what is meant by this sodium potassium tartrate? Acetic acid. When we remove H plus, you will get acetate. Formic acid. When we remove H plus, HCO minus, HCO minus is called formate. Like that, tartaric acid. It has 2 H plus ions to be donated. When we remove the 2 H plus ions, that is called tartarate. Now see the formula of tartaric acid. This is tartaric acid. Is it okay, ma'am? Now, first note down this tartaric acid. Next, I remove this H plus ions. Acid capability is to donate H plus ions. Then it will get carboxylate ion, carboxylate ion. Okay? This is called tartarate. Tartarate. Carboxylate. When H plus is removed, remaining ion is called carboxylate. Like that, here this is tartaric acid. From tartaric acid to H plus ions are removed, then it is tartarate. Here Na plus sodium, here K plus. Sodium potassium tartrate. The sodium potassium tartrate, Na, K tartrate. Sodium potassium tartrate is called Rochelle salt. When this acid reacts with NaOH and KOH, acid, NaOH, KOH, base, acid plus base, we will get salt. Correct? This is nothing but salt only. That's why they gave the name Rochelle salt. Carboxylate ions, when they are present with sodium or potassium ions, those are called salts. This is called Rochelle salt. This Rochelle salt, alkaline solution, alkaline means basic solution, is called Fehling's B. Fehling a simple aqueous CuSO4 solution. These two are mixed to form Fehling's reagent. Are you clear now? Fehling's reagent contains two solutions. Those are Fehling's A and Fehling's B. Okay. Fehling's A is called aqueous CuSO4 solution. Fehling's B is called alkaline solution of sodium potassium tartrate. These two are mixed to form Fehling's reagent. It is in blue color. In lab we will be under the label Fehling's reagent. Already it is mixed. Okay. And what about that sodium potassium tartrate? This is the thing, formula. Okay. Next. Now we will see actual reaction. RCHO, aldehyde, will undergo reaction with Fehling's reagent contains copper sulfate solution in which copper contains Cu plus 2 ion. So we are writing in ionic form Cu plus 2 plus 5 OH minus. This OH minus is obtained from alkaline. Alkaline means basic medium. Basic medium contains OH minus ions. This is simplified form of reaction. More than that no need. Okay. RCHO plus Cu plus 2 plus 5OH minus will be giving rise to RCOO minus. Again, same aldehyde will undergo oxidation to form carboxylate ion, because these are all under reactions oxidation only, but these are mild oxidizing agents which are shown by aldehydes, because aldehydes are more reactive than ketones, which are not shown by ketones, these reactions. Okay, RCO minus plus Cu2O plus H2O. Cu2O plus H2O. This Cu2O is in reddish brown precipitate. In Cu2O, oxidation state of copper is +1 now. In Cu2O, oxidation state of copper is +1. Here +2. +2 became +1. Decrease in oxidation number is called reduction. It is undergoing reduction. Aldehyde is undergoing oxidation to be formed as carboxylate ion. So this is oxidation of aldehydes. Okay, now this one will undergo oxidation to form RCO minus, and in the precipitate, if you see the precipitate, that is aldehyde. So given compound will be taken in tissue. To that we will add Fehling's reagent. If you get brown precipitate, reddish brown precipitate, immediately you can understand that is contained by aldehyde. If you don't get the precipitate, that is nothing but ketone. Okay, in this way we can understand how we will differentiate aldehyde and ketone. All clear? This is about oxidation reactions. Under oxidation reactions, we have seen first aldehydes, how they will undergo oxidation. Second, ketones, how they will undergo oxidation. Third, tolerance reagent, that is tolerance test. Silver mirror is formed. The tolerance test is also called silver mirror test. Tolerance test is also called silver mirror test. Fourth one, Fehling's test. Fehling's test is done by Fehling's reagent. How Fehling's reagent is prepared, we have seen by combining Fehling's A and Fehling B. Then, if this aldehyde reacts with this Fehling's reagent, what is the color we will get? Reddish brown precipitate. By that we will come to know whether aldehyde is present or not. Then, started with carbonyl carbon, ended with which functional group. In this way, we can differentiate. These are confirmatory tests for aldehydes or ketones. If the substance is not giving tolerance test or Fehling's test, then we will come to know that is called ketone. Okay, ma'am? Next. One more is there under oxidation itself, that is fifth one. Reaction with NaOCl. Reaction with NaOCl. This NaOCl, reaction with NaOCl, can also be written with reagent as NaOH plus Cl2. NaOH plus Cl2. Now, what about the specialty of this reaction? Let us consider RC double bond OH. Actually, this R must be definitely CH3 one. CH3 C double bond OH. Okay. What is the importance of the reaction? In next class I will say. First, note down the reaction itself. After that, we will continue. No problem. Okay. Now, CH3CHO reacts with NaOCl, in which correctly this CH3 group, it is converted to CHCl3. Whatever the CH3 group bonded with C double bond O, it is converted to CHCl3, which is called chloroform. Remaining, how many carbons we have? Remaining substance fully, how many carbons we have? 1 carbon. We will get with 1 carbon carboxylate ion. With 1 carbon carboxylic acid, it is obtained as carboxylate ion. Okay, so this one alone, it is converted to carboxylate ion. Oxidation on aldehyde group is converted to acid, but it is obtained in the form of carboxylate ion, HCOO minus. Okay, I will write one more example. In textbook they give big example like this: CH3 CH double bond C, here H, C double bond O, CH3. Like that, one example they have taken. Definitely, if reaction with NaOCl, we have to see that this type of group must be there, CH3CO. That importance in next class I will say. Once again I told. Okay, now this one is going to react with NaOCl. Same thing. Correctly, C double bond is bonded to CH3, na? This CH3 which is bonded to C double bond O is converted to CHCl3 chloroform plus remaining substance same as it is. Remaining how many carbons we have with the carboxylic is formed. Now I will write that one. See, CH3 CH double bond CH C double bond O minus. See, let's remaining same as it is, no? C double bond O minus. Are you clear? Correctly, where that CH3 is there, that CH3 alone it is converted to CHCl3. Mechanism no need, no? Okay. Correctly, that CH3 alone it is converted to CHCl3. Remaining total substance it is converted to carboxylate ion. Remaining total substance C double bond O is oxidized to C double bond O minus carboxylate ion. Double bond won't be disturbed. Same as it is, double bond will be getting. Okay. Now this type of thing, reaction with NaOCl, can be undergone by aldehydes or ketones also. Can be undergone by aldehydes or ketones. But what is the specialty of this one? Definitely that aldehyde or ketone must contain CH3 C double bond O. Methyl carbonyl group. Requirement for this to undergo reaction is that might be aldehyde or ketone, but it should contain CH3 C double bond O. Okay. What is the specialty of this reaction? This is like chloroform reaction. Like this we have iodoform reaction. In next class we will see that iodoform reaction. What about that reaction? All those things. So by that oxidation reaction will be completed. This is third one. Fourth one, reactions of aldehydes or ketones due to alpha hydrogens. Next one we will continue in that class. Okay, man. Till this today's class, I hope you understood everything. If you have any doubts, I told already, you can just WhatsApp me. I will clarify. Is it okay, man? Thank you. Thank you all.